Hello, grade 11s. Last week we were introduced to the mole concept and learned how to do various calculations with the mole. We learned how to convert an amount in moles to a number of particles, as well as the opposite calculation, using the number of particles to calculate how many moles are in a sample. We also learned about molar mass and how to calculate it for both individual elements as well as for more complex compounds. This online lecture is going to focus on Chapter 6.1, which is Chemical Proportions and Percentage Compositions. By the end of this lesson, you're going to be able to define the law of definite proportions, calculate the mass percent of various elements in compounds using molar mass and mass data, and you're going to be able to calculate percentage composition of various compounds using molar mass and mass data. The law of definite proportions states that a chemical compound always contains the same proportions of elements by mass. For example, if we compare water molecules in, say, a lake, snow, or ice, we know that they will all be composed of 2 hydrogen atoms and 1 oxygen atom. We know this because of the chemical formula of water is H2O, 2 hydrogen, 1 oxygen. This ratio never changes. So in a lake, snow, and ice, we find the same type of water molecules. The mass of 1 mole of water is 18.02 grams, consisting of approximately 2 grams of hydrogen and 16 grams of oxygen. The mass percent is the mass of an element in a compound expressed as a percentage of the total mass of that compound. To determine the mass percent of an element in a compound, you must divide the mass of each element by the mass of the compound and multiply by 100%. Again, taking the example of water, we can calculate the mass percent of hydrogen in water with the following formula. Mass percent of hydrogen is going to equal the mass of hydrogen divided by the mass of water multiplied by 100%. And again, the mass of hydrogen from our periodic table, we can convert the atomic mass units to molar mass. We get 2.02 grams divided by the molar mass of water, which is 18.02 grams. Multiply that by 100%, and we get the mass percent of hydrogen as 11.2%. The mass percent of hydrogen in water will never change. It will always be 11.2% of any sample of water due to the ratio of hydrogen to oxygen in the formula for water. Take a moment to try this practice problem and feel free to push pause on the video so that you can have time to work it out before you can see the answer. In order to answer this question, we have to look at what we're given. Now, an easy calculation from the periodic table will give us the molar mass of the compound as 71.85 grams per mole. We're required to find the mass percent of oxygen. How are we going to do this? Well, we have our formula for the mass percent of oxygen. We're going to take the mass of 1 mole of oxygen divided by the mass of a 1 mole sample of this iron 2 oxide compound, and we're going to multiply it by 100%. Let's solve this together. So, the mass percent of oxygen equals the mass of 1 mole of oxygen, which we know is 16 grams, divided by the mass of 1 mole of the sample, which is 71.85 grams, times 100%, we get 22.3%. So the mass percent of oxygen in iron 2 oxide is 22.3%. So this is one way that we can calculate the mass percent of an element in a particular compound. We can also calculate mass percent based on mass data obtained from an actual experiment. Again, take a moment to try this example, push pause on the video, in order to figure out this new calculation where we're using masses from actual experimental data.
So for this solution, just for the sake of time, I've written down my givens as the mass of the sample is 30 grams and the mass of carbon as 8.2 grams determined experimentally. What is required? Well, the question's asking us to find the mass percent of carbon. How will we do that? we're going to use that same formula as before, where the mass percent of carbon is the mass of carbon in the sample divided by the mass of the sample multiplied by 100%. So let's do that now. So mass percent of carbon equals the mass of carbon in the sample, 8.2 grams, divided by the mass of the entire sample, 30 grams, times 100%. Okay, so we should get 27.3%. And then if we were to go to do our statement, we would say the mass percent of carbon in the compound is 27.3%.
The law of definite proportions helped us to understand compounds that contain the same elements in the same proportions, like water in our example. But there are also compounds that contain the same elements in different proportions. And in this case, the structure of a molecule or compound will cause a substance to have particular properties, as we know. This concept can be illustrated using the comparison of carbon monoxide, which is CO, and carbon dioxide, CO2. The chemical formula for carbon monoxide is similar to that of carbon dioxide, as we can see both contain carbon and oxygen atoms. However, the difference in the number of oxygen atoms per molecule causes each gas to have very different properties. Carbon monoxide, for example, is a colorless, odorless gas that is very poisonous, whereas carbon dioxide is a colorless, odorless gas that is essential to life. Even though carbon monoxide and carbon dioxide are similar, they have very different properties. This comparison illustrates that the properties of a substance depend on the elements the compound is composed of, as well as the quantities of each element in that compound. Another important concept in this chapter is percentage composition. Now, to get percentage composition, we just calculate the percent mass of each element in that compound. And together, all of those percent mass items are going to add up to 100%, giving our percent composition for that compound. For example, the percentage composition of nitrogen dioxide gas, we can calculate it by finding the mass percent of nitrogen and the mass percent of oxygen. Now, because nitrogen and oxygen are the only two elements in that compound, their mass percents, when we add them up, should equal to 100%. Percent composition is a very important concept, as it allows scientists to determine the identity and composition of newly discovered chemical compounds. For example, vitamin C is an important molecule in the growth and repair of body tissues. Human bodies can't synthesize this vitamin, so we must instead obtain it through our diet. Some people don't obtain enough vitamin C through their diet and must take supplements of vitamin C, which are synthesized. In order to synthesize it, scientists need to determine the composition and structure of the original molecule. That's where percent composition comes in. Try the following question by using the mass percents of each element in the compound to determine the percentage composition of the entire compound.
To solve this question, we first have to look at what we're given in the question. So we're given the mass of the sample as 35.8 grams. The mass of carbon in the sample is 30.10 grams, and the mass of hydrogen in the sample is 5.70 grams. Required of us is to find the percentage composition of that compound. How are we going to do this? Well, we're going to use that same formula that we've been using to find the mass percent of carbon and hydrogen, the only two elements in that compound. So let's begin by solving for the mass percent of carbon, which is 30.10 grams divided by the mass of the sample, 35.8 grams, multiplied by 100%, and we should get 84.1% as the mass percent of carbon. To get the mass percent of hydrogen, we're going to do the same thing, taking its mass 5.70 grams, as well as the mass of the compound multiplied by 100%, and we should get 15.9%. An easier way to do this, because this compound is only composed of 2 elements, we could have just taken the mass percent of carbon and subtracted that from 100%. Both ways, we get 15.9% as the composition of the remaining element. Now, this only works if there are 2 elements in that compound.
If we're not given experimental mass data, we can still determine the percentage composition of a compound from its chemical formula. We did this before with mass percent, and essentially, because percentage composition is just finding the mass percent of each element in that compound, we can refer back to that same formula. Take a moment to try this last problem, which is asking for percentage composition. Looking back at the goals for this lesson, we are now able to define the law of definite proportions, calculate the mass percent of various elements in compounds using both the molar mass and mass data approach, and we're able to calculate percentage composition of various compounds using molar mass and mass data. The homework for today's lesson is under Index 5, where you have a variety of practice problems and review questions that you can practice the calculations from today, and we'll take up any of those questions as well as any other questions you might have about these topics tomorrow in class.